This is a video for AQA Further Pure Mathematics. It's Roots of Equations section 1.2, where we're going to be using the relationships developed in section 1.1. Well, in section 1.1 we found that for the general quadratic equation the sum of the roots alpha plus beta was equal to negative b over a, and the product of the roots alpha beta was equal to c over a. So that a straightforward question that we might be asked would simply be to find the sum and the product of the roots in this situation here. Well, from the equation 3x squared plus 2x minus 6 is equal to 0, we can read off the coefficients so that therefore a is equal to 3, b is equal to 2, and c is equal to negative 6. And we can quote our results then that the sum of the roots alpha plus beta must be equal to minus b over a, and therefore that's equal to negative 2 over 3. The product of the roots alpha beta is equal to c over a, and therefore that's equal to negative 6 divided by 3, which of course is negative 2. Well, for a cubic equation we found the following results: that the sum of the roots is equal to minus b over a, the pairwise product of the roots is c over a, and finally the product is minus d over a. So again, in this situation then we're simply asked to find the sum of the roots, the pairwise product sum, and alpha beta gamma, the product of the roots. So we can see here that we have a situation where a is equal to 2, b is equal to negative 1, c is equal to negative 2, and d is equal to 1. Therefore, our sum alpha plus beta plus gamma, which is minus b over a, must be equal to negative of negative 1 over 2, which is equal to 1/2. The pairwise products sum alpha beta plus beta gamma plus gamma alpha is equal to c over a, so that's equal to negative 2 divided by 2, which is equal to negative 1. And finally the product alpha beta gamma is equal to minus of d over a, so that's equal to minus 1 over 2, so negative 1/2. Well, now we're going to look at a slightly more complex situation where we're asked this time to find alpha squared plus beta squared plus gamma squared. Now, of course, we don't actually have a result for alpha squared plus beta squared plus gamma squared, so we've got to be a little bit ingenious in working out how we can find that. Well, the first thing we do is we note if we look at alpha plus beta plus gamma all squared, then that will be equal to obviously alpha plus beta plus gamma multiplied by itself, alpha plus beta plus gamma. And we can calculate that by taking each of the terms in the first bracket, alpha, and multiplying by the second bracket, alpha plus beta plus gamma. And then obviously beta times alpha plus beta plus gamma, and finally gamma multiplied by alpha plus beta plus gamma. So multiplying out the first bracket, we get alpha squared plus alpha beta plus alpha gamma. The second one is alpha beta plus beta squared plus beta gamma. And finally, alpha gamma, beta gamma, and gamma squared. So you see now we've got the terms that we want, which is the alpha squared, beta squared, and gamma squared. But we've also got some pairwise things, and if you look at it carefully, you'll see that we've got 6 of them. So we've got 2 of each of the pairwise. So we've also got plus 2 times alpha beta, beta gamma, and gamma alpha, our pairswise products. Now we know then that from our roots of cubics, we know that alpha plus beta plus gamma, the sum of the roots is equal to minus of b over a, and so we can calculate that as being equal to 1/2. And we know also that the pairswise alpha beta plus beta gamma plus gamma alpha is equal to c over a, so that's equal to -1. So substituting those into the above equation, then we have alpha plus beta plus gamma all squared, so that's 1/2 all squared, is equal to alpha squared plus beta squared plus gamma squared, the thing we're trying to find, alpha squared plus beta squared plus gamma squared, and then finally 2 times the pairwise product, so 2 times -1. So rearranging that, we find that alpha squared plus beta squared plus gamma squared is equal to 1/2 squared, which is 1/4, and then plus 2, or in total therefore 9/4. There it is, all typed out nice and neatly for you to have a look at. Now usually you're given some guidance in how to find these rather more difficult examples. So for example, the questions may well ask you to find alpha plus beta plus gamma all squared and hence calculate alpha squared plus beta squared plus gamma squared. Well, that's the end of this video. In the next one we'll be looking at forming equations where we've got related roots.